Okay, today's lesson is going to start with 2.3G, finding slope from a context, and it's on page 106 in your binder. Okay, so on page 106, we're looking at number 1, and it starts off and it gives us a table. We see the table is half filled with numbers, but it tells us that this topic is about gourmet jelly beans, and these jelly beans cost $9 for 2 pounds. So complete the table. Well, I see this $9 for 2 pounds, and down here I see $9, which means this has to be 2 pounds. Okay, and then I need to figure out, well, what is it that the rest of these numbers are going to equal? So if you are paying $9 for 2 pounds, then I know that it's $4.50 for 1 pound. So that's what I'm going to base everything off of, being $4.50 for 1 pound. Now, I see here half a pound, so I need to think, well, what's half of 450? And that's going to be $2.25. Okay, 3 pounds. So if I know 2 is 9, I'm going to 3. I just need to add another 450 to that for the extra pound. So 9 plus 450 would give you 1350. 4 pounds, I would add another 450. So 1750 plus 50 cents, so that'd be $18. Okay, and then I look at what's going on here, $27. So this went from 18 to 27. 18 to 27 is an increase of 9. And we know that 9 represents 2 more pounds. So 4 plus 2 would give you 6. Okay, and then I see the next pounds, 6 to 8, that's 2 more pounds. And we just talked about 2 pounds being $9. So I'd add $9 more on the 27, get 36. Same with this, 2 more pounds, $9 more, 45. And then I see that there's a blank spot here, so you can put whatever number you want there. So maybe I'll just say just 1 more pound, so like 11. And if it's 11 pounds, I need to add 450 more onto the 45, so that'd be 49.50. And then last 20 pounds. Well, I see 10 is 45, so 20 I could just double that. So 20 is going to be $90. Okay, so that part B says graph and label that relationship. So I'm looking at my pounds, which has got to be my X, and then my total cost is always the Y. So X, Y. So down here is going to be pounds. Over here is total cost. Okay, the pounds I see, I need to get all the way up to 20. So we have to start at 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it looks like there's going to be enough to get 20 on here, so I'm going to go by ones here on the x-axis. And the cost for the y, 90, well, there's definitely not 90 spots, but I think an appropriate one would be like every box being 10. So like 10, 20, 30, so on. And I see I will have enough room because I can get all the way up to 100 with that. And then I'm going to count by everyone's going to be 1, but I'm not going to label everyone. I'm going to go label like maybe every 2. Perfect. Now we're going to graph that data. So at 0.5 it's $2.25. So 0.5 means you got to go like, if here is 1, I need to go halfway here, and $2.25. Well, this is 10 up here, so I think, well, this is like 5, and it's got to be less than half of that, so it's pretty close to like right here. Okay, at 2, it's 9, so here's 2, and there's 9, almost up to 10, but not quite. 3, it's going to be at 13.50. So here's 3, and I know like right here would be about 15, but it's going to be a little less than that. So there we go. 4 is going to be up to 18. And if I'm graphing it, I should end up with a straight line because it has a constant rate of change here. So if it's not straight, you're off a little bit. So 6 is going to be 27. 8, 36. 10, all the way up to 45. 11, he said 49.50, so almost up to 50. And then 20 is all the way up to 90. Alright, so this should be a straight line. I know it's going to be it looks like most of the points there are in order, with the exception of that one just being a little bit off. Okay. Part C, what is the slope of this line? Well, the slope refers to your rate of change. Okay, your slope is your rate of change. And we knew that it was $9 per 2 pounds. Okay, so we could say that, or we could say $4.50 for 1 pound. So because we went to the slope here, the funny thing about slope is that they don't like to have decimals in it. So the rate of change might be $4.50 per 1 pound, but the slope, we're going to leave it as whole number. So we're going to say, it'd be like 9/2, but we're just going to write it like that, 9/2. And what is the slope? Write the slope of the line as a rate of change. So that means that we can say it's $9 for 2 pounds, or $4.50 for 1 pound. So that'd be our rate of change, $4.50 per 1 pound. And that basically is what it means. So we have $4.50 for 1 pound of jelly beans. Now, write an equation to find the cost for any amount of jelly beans. So our equation is going to start with y equals. And then I think, was there any initial cost? Well, no, the graph starts at 0. So there's no additional cost, which would be represented by a point somewhere up here on the y-axis. So instead we think, well, what was the rate of change compared to 1 of something? So it's $4.50. So we're going to say $4.50 times x, where x represents the number of pounds. So if I take the number of pounds times $4.50, that gives you the total cost. And then letter F. Letter F says, why is the data graphed only in the first quadrant? So within graph systems, we have coordinate systems. We have a graph like this usually. And then we have, this is quadrant 1, that's 2, that's 3, and this is 4. So if you recall, it goes by Roman numerals. And quadrant 1 is the only one that we're using in this set of data points here. And we're using that one because everything in quadrant 1 is positive, positive. Which makes sense when you talk about jelly beans, because you're not going to go into negative pounds for jelly beans. You're not going to go into a negative cost for jelly beans either. So when it asks why is it graphed in the first quadrant, we can simply say that. You won't get negative pounds of jelly beans, or a negative cost. Okay, part 2. Part 2 says, Kaylin takes the same amount of time to solve each of the equations on her math homework. She can solve 10 equations in 8 minutes. Alright, so see if you guys can go ahead and figure out how to fill in the table. Okay, so when you were filling it in, you were looking here, equations. I see 10 equations in 8 minutes. So in this case, x is our minutes, and equation solved is your y. And I see up here 8 minutes, 10 equations. So right here's my 8, which means 10 has to go here. Now, if you can do 10 equations in 8 minutes, then you think, well, I can do 5 equations in 4 minutes. And then you can even break it down maybe even further. So 5 equations in 4 minutes, but then you're like, well, 2. So how many minutes? So if 5 is to 4, then I could say, well, 2.5 is to 2. So you can do 2.5 equations in 2 minutes. Okay? And then if I'm going to solve 2.5 equations, well, if I go to 5, I'm just doubling that. So that would take me 4 minutes, which we represented up here. 5 equations in 4 minutes. And then moving right along here, we see equations solved. We jump up to 15. So we solved another 5 equations. And we knew it was 5 equations for every 4 minutes, so I have to add 4 minutes onto the 8, which you would have got 12. Okay, this blank spot, you can put whatever you want in there. Maybe we'll say 20, because we're counting by 5s, there. So if I go 5 more equations, that's going to be 4 more minutes. So 16. And then I see here, there's 4 more minutes. So if it's 4 more minutes, that's going to be 5 more equations, 25. And then I have 5 more equations, so that's going to be 4 more minutes at 24. Okay, go ahead and graph that line, and then we'll see if your graph looks like mine. Okay, if you graph the line, you get like 0. I see that we go all the way up to 30 and 24. So for X minutes, I can go by maybe 2's on this one. That is pretty small. And then minutes, I'm going to go by 2's as well. But because it's so small, I'm going to label like every 5. 1, 2, 3, 4, 5, and so on. Okay, for the sake of time, I'm going to start graphing this. So, actually, for the sake of time, I'm going to have you guys graph, and then we can compare and see if you got the same thing. Okay, for part C, what is the slope of the line? Well, the slope of the line is when you compare to one of something we don't want decimals. We break it down as far as we can, reduce it. So that was this right here, 5/4. So my slope is going to be 5/4. And what does that mean? Well, as a rate of change, it was 5 equations for every 4 minutes. And then you're going to write an equation, find the number of equations solved for any number of minutes. So in this case, we see that it's going to be y equals, you don't start with any equations, so there's nothing to start back there. But 5/4, and then I want to think, well, how many minutes? What can I do is 5 equations for 4 minutes. Well, in this case, you need to break it down to one of something. So 5 divided by 4, if I do that, 5 divided by 4, you're going to get 1.25. Okay, so we always want to compare to the one of something when we write the equation. So my equation would be y equals 1.25x, because you can solve 1.25 equations every 1 minute. Okay, that is the end of the lesson for today.